All right, we're going to look at this next example. The top equation contains x squared and y squared. The bottom equation contains just x and y. So if we tried to use the elimination method, it would not work because I don't have any like terms from top to bottom. The x squared on top does not have a corresponding x squared on the bottom. The y squared on top does not have a corresponding y squared on the bottom. I have no way to cancel out either of those variables because they don't have corresponding like terms in the opposite equation. Elimination won't work. That means that substitution is going to be the way to go. So now the question becomes, what do I substitute where? And I would suggest go with the easier looking equation. All right, the easier one to me is the bottom equation, x plus y equals 7, because it doesn't have all those squares that get in the way. So I'm going to focus on that second equation, x plus y equals 7. Okay, now what do you do with that? Well, you're going to solve that equation for one of the variables. Well, which one? Well, in this case, it doesn't matter because if you look at the top equation, it has an x squared and a y squared. It doesn't have just an x or just a y along with that x squared, y squared. And so you can actually solve for either of these two variables and then make that substitution into the top equation. Let's just solve for x. So x is equal to 7 minus y. Try something, and if it's not leading you down a path where you can see your destination, well then scrap that idea and try something different. So I'm going to substitute the quantity 7 minus y for x back up here into that top equation in place of the x. And that's going to give you an equation that is only in terms of y. Okay, so there's your equation that's just in terms of y. You're going to simplify by getting rid of parentheses. You're going to combine any like terms that you might have, and you're going to solve for that variable. Okay, so let's drop those parentheses by foiling the quantity 7 minus y squared. And so 7 minus y squared, if you don't want to write it out side by side, you may. You're going to get 49 minus 14y plus y squared. Then there's a minus y squared after the parentheses, and that's equal to 21. So the y squared and the minus y squared give you 0. And now you have 49 minus 14y equals 21. Solving for y, so we want the y term by itself, which means we have to get rid of this constant. Move it over to the other side. So you'll have negative 14y equals negative 28. And you divide each side by negative 14. Get the y by itself, y equals 2. Y equals 2. Now you're going to figure out the corresponding value for x. You're going to substitute the value y equals 2 into both equations, and in each case you should get the same answer for x. Let's try the top equation. So the top equation, replace the y with the value 2. All right, so you got x squared minus 2 squared equals 21. So x squared minus 4 equals 21. So x squared equals 25. X is plus or minus 5. Okay, now for both of those to be real solutions and not extraneous solutions, they would have to also be achieved in that second equation. So the second equation, solve for x, replace the variable y with the value 2, okay? You get x equals 5. You do not get negative 5. And so now the answer is just 5. Negative 5 doesn't work in the second equation, and therefore it's not an actual solution. So the only solution we have to report is the ordered pair 5, 2. All right, here we go, number 30. Once again, we don't need to worry about the graphs of these two equations, but if you would like to, I would suggest not using your graphing calculator. It's going to be too tedious because your graphing calculator wants it in the form y equals, and the top equation is clearly not. It involves a lot of work to get it there. So if you have, if you want to use the application or the website desmos.com, that's a great graphing tool. You can type that equation in and get a graph of it if you like. But we're not going to worry about that. All right. Notice that the top equation has a minus xy term, and the bottom also has a positive xy term. Now, I could add those two equations together by combining like terms from top to bottom, and the xy term would go away. Okay, but that's going to leave you with a resultant equation in terms of two variables. Okay, and that's no good because what you need is a resultant equation that is just in terms of one variable. And so that was not useful. So you have to think of another method that you might use to solve this system of equations. Some kind of substitution is going to be your best bet right now. You maybe want to, well, I would recommend trying to figure out which equation looks more simple to you. And I think we can agree that that would be the second equation. So let's take that second equation and solve for the variable x. If we solve that second equation for x, xy equals 4 would say x equals 4 over y. Okay, you could have solved it for y and the process would be identical, but I chose to solve this one for x, right? What I have is an expression that I can replace the variable x with up there in the other equation, in the opposite equation, right? So had you chosen to solve this equation for y, you would be substituting your expression back in for the y. But it doesn't matter. What you're going to have is an equation that just has one variable remaining. So in this case, it's going to say 2 times, instead of x, I'm going to use 4 over y and square that quantity, minus, instead of the x, I'm going to use the quantity 4 over y times y, plus y squared won't change, is equal to 8, right? So I have an equation now that is only in terms of y, which is what we needed. So if I simplify, 2 times 16 over y squared minus, the y's cancel out on that one, so minus 4, plus y squared equals 8, or 32 over y squared, plus y squared equals 12. Let's just move that negative 4 over, get it out of the way. All right, so now I've got an equation. It's rational. It's rational. Remember rational equations. We learned how to solve rational equations, which is where the equation has a variable on the bottom. Back in one of the appendix sections, one of the A sections. So one technique that we discussed, which is very useful, is multiplying the entire equation by the LCD. The LCD, the least common denominator, all the way through. Okay, so the least common denominator is going to be y squared. So every single piece of this equation gets multiplied by y squared, and that is going to eliminate the denominator of y squared, right? Because on the first time through, you're going to get 32. Those y squareds will cancel out. Next, y squared times y squared is y to the 4th, and on the other side, 12 times y squared is 12y squared. And I'm going to move everything to the left-hand side, and we'll decide what to do from there. Okay, so it kind of looks like a problem where I would have to factor in order to solve for my variable, because I was using that now for a few different cases where I had quadratic equations. This one isn't really quadratic, is it? It's y to the 4th. It's a 4th degree, it's not 2nd degree. But it's going to be dealt with in about the same way. What you do want to look for is two binomials that you would multiply together to give you that expanded form. And so I'm going to use y squared in those first positions. Y squared times y squared would give me that y to the 4th when I would go with the FOIL at the end here to see if I have it right. Okay. I'm not going to worry about this y squared in the middle. That's gonna work itself out. Now I'm looking for two numbers that multiply to positive 32 and add to negative 12. Okay. So factors of 32 are going to be 1 and 32, 2 and 16, 4 and 8. And that's all I can think of. I think that's it. And so the only combination that's going to work there is the 4 and the 8. They both have to be negatives because, once again, that product is positive 32. So I think this is going to work for us, and we're going to FOIL to check. So if I FOIL this, these two binomials, y squared times y squared is y to the 4th. Y squared times negative 8 is negative 8y squared. Here in the middle, I have negative 4y squared. Well, the negative 8y squared and the negative 4y squared are like terms, and that gives you negative 12y squared, which is great because that's what I was supposed to have back here. And then at the end, negative 4 times negative 8 is positive 32. We got it. Okay, so we get two expressions, or two equations out of this. Y squared minus 4 equals 0, and y squared minus 8 equals 0. So on the left side, y is equal to plus or minus 2. And over here, y is equal to plus and minus 8, which is plus or minus 2 root 2. All right. All that work, and that just found us the values for y, for the ordered pairs of the intersection points. Okay, next we have to go and find the x's. All right, so theoretically, I should be plugging in the 4 separate values that I just came up with for y into both equations to find those corresponding x's. But let me save you some time right now, and I'll just tell you that these are all going to work in both equations. And so I'm just going to focus on that second equation. In fact, I'm going to focus on this version of that second equation because it's even better. All right, so let's first look for the corresponding x coordinate for when y is equal to 2. Okay, so if y is equal to 2, x is equal to 4 over 2. 4 over 2 is 2. So that gives you the ordered pair 2, 2. All right, what happens when y is equal to negative 2? That means that x is equal to 4 over negative 2, and that's negative 2. So I got negative 2 on that. How about y equals 2 root 2? If y equals 2 root 2, well, that means that x equals, all right, now this involves a little bit of work, doesn't it? X equals 4 divided by 2 root 2. Going up here with it. X equals 4 divided by 2 root 2. And that's, let's see, that reduces to 2 divided by root 2. And I have to rationalize the denominator. And I get 2 root 2 over 2. And that's just, the square root of 2. Okay, square root of 2. And then if y is equal to negative 2 root 2, all that work is the same, but the value at the end is going to be negative. Great. So that gives you the other 2 ordered pairs of square root of 2, comma, 2 root 2, and then negative square root of 2 for x, and then negative 2 root 2 for y. So your 4 solutions are here and here. And like I said, theoretically, you need to check all of that work into this equation to make sure all of those x values come out to be the same. But let me save you the effort and just tell you that they will. Okay.